Alright, welcome back. We are now about to complete what we have left in our devices, and the next device, the third type of devices that we are about to talk about, will be two types of devices actually, which are firewalls and IPS, net intrusion prevention systems. These are security devices, not normal or ordinary routing and all networking devices. Firewalls and intrusion prevention systems, IPS, are two types of all devices that were used in the networks. First one is firewalls. Firewalls protects you from the internet and from any attack that comes to you from the internet, from anyone who would like to penetrate what was called, this is a security term, penetrate your network and take your private information, maybe steal them, maybe inject some viruses or other hacking tools inside your network. So firewalls, the device that was meant to protect you from the internet. Another benefit for the firewalls, it would be to apply some restrictions to your local network. So you can use firewalls, as you have understood me, with LANs and WANs together. Using them, and LAN was the first purpose because it is protecting you from the internet. So you have like your PCs this way, have more than a single PC connected to a single switch, and this switch is connected to a router. Okay, this is your LAN. If you have understood me so far, in the previous lecture we have talked about LANs. Okay, first benefit, okay, let's mention the second before the first. The second benefit, okay, let's mention it firstly, is that you can apply some restrictions inside your network by using a firewall. Maybe you can place your firewall in this place, okay, and firewall should be connected to another router in another department, because inside the company we are still called a LAN, a local area network, and in this other department there is other users. This is how you can express end devices. You can just take a line with a short perpendicular line upon it. That's enough for expressing an end device. Just like this icon express a switch, this one express a router, if they are clear enough. Okay, this one can express any end device, server, a computer, personal computer, an IP phone or a printer, no problem. Anyway, so you can place a firewall inside our network to apply some restrictions, some things that are allowed from this department to the other things that are denied from this department to the another, or can be used or applied using firewalls. Another benefit from firewall is that having your local area network, these are two devices connected to a router. This is your router. This router is connected. Don't think that this is strange. This cloud represents, this is a U. This cloud represents the internet. Okay, this is the symbol of the internet, where there is tons of devices connected together, bringing to us the information we need from google.com, from other websites, from the internet entirely. Okay, a cloud. So your network connected to your router and connected to the internet, that will allow any intrusion or anything to get inside your network. So we will need to place a firewall between our network, on the edge between our network and the internet, to protect ourselves. This is what firewalls would do, okay? And this is how a firewall looks like. Alright, these are a lot of types of firewalls. Mostly, if you had studied CCNA security before, the most used devices in a firewall was called Adaptive Security Appliance, which is Cisco ASA, and this is Cisco's firewall. These are different models of the firewalls and how do they look like. The other type of firewalls of security devices is called intrusion prevention systems, or IPS. IPS were devices used to function two main functions, which the first one was to do a deep packet inspection, a DPI. This is a security function we will discuss in the security chapter. Another function to it was to try to spot attacks. Okay, so this was to be applied even before the firewall. So you will have your network, your router, your firewall, your IPS, and then the network. That would be enough to protect your network. This one, not as much as a firewall to protect you, but it will detect the attacks that will happen to you, and even if no attack, if nothing harmful is happening to your network, its other function was to do a deep packet inspection, so that deeply it will tell you every packet that is going from or to your network. What is that packet? Don't be. Term packet will be discussed later. Okay, what does a packet mean? It's a network information traveling, okay, through the internet. It's called a packet. Okay, every single packet that is traveling from or to your network will be declared by using the DPI, the deep packet inspection, and this is one of the Cisco's IPS, intrusion prevention systems devices. Okay. There is a two-in-one solution that came later by Cisco Technologies, which was called Next Generation Firewalls, or a shortcut which is NGFW. Next Generation Firewalls are a new device, one security device that do merge both the firewall and the IPS. This is not the first time that Cisco do merge two devices in a single device and can function entirely like whatever you would like. We have just talked about this in the previous lecture, where we said that there is a multi-layer switch that combines routers and switches and give you full resiliency for whatever function you would like. Cisco also have done this step again, or this method of combining or merging devices again in the next generation firewalls by merging the firewalls and the intrusion prevention system. These are two types of security devices of Cisco. Next, we have access points. This is a wireless device, and we will talk about it in details in the wireless chapter. That will be chapter 6, I believe. Access points, they are like switches. In some functions you can compare access points to switches. I will say, we will just explain which function is this exactly. Access points, a shortcut for them is the APs. Okay, most of them we will see it's APs. Okay, APs, access points, are the wireless destination for a host. What do you mean by a host? Your PC, or even a printer or server or whatever, your end device. Wherever you see end device, by end device I mean the 4 devices or even more than the 4 devices that I have mentioned previously that a human uses directly. Access points, like switches, access points are the wireless destinations for a host to communicate with other hosts. So before, in local area networks, in the normal ordinary old networks, what we had is a switch that is connecting end devices together. This is the symbol of an end device, this is the symbol of a switch. Yes, so in order for any end device to talk with any other end device for sharing or requesting any information, we need to be connected together using a device, which was a switch. Whether it was a layer 2 or a layer 3 switch, the multi-layer switch, no problem, no matter. Okay, this is how things used to happen. It was was what called the wired which was called the wired networks. In wired networks, we need cables from PC1 to switch, from PC2 to switch, cables in everywhere just to connect all these devices to the switch. In the wireless networks, we need access points. Access points do not be mounted on a rack, they can be mounted on the wall. You can just have your wall and this access point with its antennas can be mounted on the wall and can be configured to become the next direct destination for PCs, just like switches. So now you have mobile phone and a computer and a server and a printer. No, this is not a printer at all. Maybe like this way with paper. Okay, and your printers, all of them are connected wirelessly. These are the frequencies of the wireless networking, okay, to the access points. No cables are needed, no wires are needed. This is a wireless network. So access points are the first destination for a host or end device to communicate with. Access point you merge or do give the ability or communication for all the devices together, just like a normal switch. After that, you can connect this single access point to a real switch. So you can have like this way. This is never something strange, okay? You can have a switch with its ports. Each port is connected to a single access point and a single floor, like an hotel or like in any normal bank or company or whatever enterprise environment that you are working with. So now, before, what we had is like, imagine we have a company or a hotel of 6 stories, 6 floors. Each floor has like 20 users, no matter how the user wants to connect, but all of them want networks and all of them want internet. Okay, so previously, I'm sorry, what we had to do was a switch in every floor and cables for each device and cables between floors to connect the switches together, and that was a normal local area network, a LAN. With the use of access point, you can have like only a single switch per floor or per building entirely, and this switch, each port of its ports are going to a single access point. This looks like an evil icon. This way, okay. Single switch connected to multiple access point. Each access point can now wirelessly give an entire floor, that depends on the switch model, depends on the coverage radius of the access point, an entire floor network accessibility and internet with no cables. So it's really normal to see an access point not just connected directly to a router to have a feed from the internet, okay, or information from the internet. You can see multiple access points connected to a single switch, and that single switch will be connected to the router. Okay, this will simplify your network and will reduce a lot of cable amounts needed. Okay, so you can see access point connected directly to a switch. Also, don't forget, having a switch in your network will allow to your access points to communicate together, because this access point, if it wanted to connect to this access point and share information between them, you will need physical medium, a shared medium between them, which is the switch. Okay, if a single device connected wirelessly to this access point needed something from another floor or to share information with another device and another access point, that will happen through the switch. So this is the function of using access points with switches. That is the first. Second thing, you can see switch access points connected directly to routers and then to internet, whatever. But most cases you will see access point connected to switches. After that, from the switches to the routers and to the internet. That depends on your network and how it is designed. Okay. Next, we have controllers, something new to be mentioned in the course. Not the wireless controller. The other type of controller we'll talk about is something extremely new. Controllers are devices that are meant to become a central management point for multiple APS. Just a few minutes ago, we said that multiple access points can be connected directly using cables or wires to a switch to communicate with each other, or you can have this type of topology of multiple access point connected to what is called wireless controller. I think the shortcut would be WLC for the wireless controller. Okay, wireless controllers. Okay, connected to a WLC or your access points connected to a switch and then to the WLC. The function of the wireless controller is a central management point for multiple IPS, because in the upcoming chapters, or firstly, in the end of this chapter, we will start our practical side and our practical labs to be configured and to be shown to you, and what exactly do you need to perform practical function or practical lab environment for this course. You will see that routers and switches, you will need the device itself, and you can connect your PC, your computer or your laptop, to this router or switch, and after that you can change the settings of the device on whatever configuration or profile that you would like to need, or that you would like or you would need to apply it, so you can obtain the function, the correct function of this device. Okay, and this is done by what is called, if you are familiar with the term, command line interface, just like the command prompt of PCs, of Windows PCs, or terminal windows of the Linux and Apple Macintosh. Okay, so you can see that through using CLIs you can apply some commands by yourself to the router or switch or firewalls, some types of firewalls, and then you will see that it functions as well. Access points rarely do this movement or this step. What you need in access point and how you make an ease of management for access point is that, just like we mentioned an example before, you have like a hotel with 6 up to maybe 15 floors. All of them are functioning the same. You will give to your customers in the hotel the same benefits and the same permissions and the same functions. All what you have to give them internet and with some rules, and that's it. So do you have to configure each one and go and connect your PC or laptop to each access point and configure it? No, you can connect all your access points to a single WLC, single wireless controller, and after that you should connect your, this is where you give your internet, just like the house DSL model, okay, the DSL, the smaller router in the house, and also connect your PC using the USB or the management port, okay, to config this WLC, and whatever configuration you apply it on this WLC will be applied to all the access points. This is not a general thing that you will be bind to. No, it's not. If you understand that whatever you do to a WLC will be applied directly to all the access points without any resiliency. No, it's not this way. But this WLC, this wireless controller, will list to you all the access points connected to it, and you can configure each one whatever you like, but from a single point of management, a single central management point for multiple access points. Just connect your laptop, your computer to this WLC. After that you can configure the entire access points that you have in your networks. You can give each one specific configuration, no problem. You can do only single configuration and apply it to all the selected access points, no problem. That is the function of a WLC, a wireless controller, or generally that is the function of a controller, because we will see a second type of controllers next which do the same thing. Okay, the second type of controllers, let us see next, will be the entire newly mentioned type of devices added to the new CCNA course, which will be the Cisco DNA Center. This is very powerful new device, and it is a controller like WLC. But if you have thought of WLC and what's the difference between a DNA center and a WLC, wireless controllers known as WLC are controllers for access points only. DNA centers are controllers for your entire networks, no matter what devices you have, types of devices, all of them Cisco, of course. The function, the amount, everything, the location, all of them. It can control and display this device, this single device. It looks like a server, by the way. We'll talk about servers. This single device have the control and shows you detailed information about the entire topology and network that you have, all of it, and you can configure whatever you like. You can see whatever you want, all the statistics, traffic, live information, configuration, whatever status for all the devices are be shown in a single graphic user interface, which is called GUI. You can also pronounce it as GUI, no problem. Okay, or in a single GUI, graphic user interface, you can see everything of your network. No need to access each device separately and show the information of each device. No need to access each device separately and do new configuration or delete old configuration from this device. DNA Center will make it possible to do everything. This is a super powerful, super capable center point of management. What it can do analytics. By analytics, it means that it gives you analytics for your entire networks. What's happening right now, how many devices are up, how many devices are down, how many devices are in risk position. If you are familiar with computers, then you can know these terms: CPU, RAM, disks, which I mean by this the hard disk drive, which is the storage places, whether it was the HDD or SSD, depends on the device or that you are using. It gives you analytics about all of them. How many devices have risk or high CPU utilization, high RAM utilization, full disks or full hard disk capacity reached out, everything, all of your networks. How much traffic right now is happening, carrying or transferring inside your network. How many devices or how many links, we will talk about links, are having a full traffic or are having congestions. All of this is shown to you. The second thing to see, if you have understood analytics so far, the second thing is automation, which means that it automates to you or give you an easy way to automatically do some functions and schedule other functions, and to give it to this device that at single time or at a specific time do shut such devices, at other specific time do unshut such devices. So you can give him the orders or configurations prior to their time and schedule these configurations and leave it. The DNA Center will do it by itself. It will do such devices will shut down, such links will be shut down, such traffic will be shifted or rerouted from another destinations, all applied per rules, per accepts and denies. Whatever you would like will be happening or applied inside the or under the automation process. The third thing we have is this: using graphic user interface to design your network. You can do it to display your network and see everything, and also you can use this graphic user interface to configure, because you will see that in routers and switches we will configure our devices in this network in the upcoming chapters and practical lectures. We will configure it using what is called the command line interface, the CLI, which is commands that we type in using the keyboard, and we type each command separately so that we type it in the way that we want the device to function. But DNA allow you to have a screen with your devices connected together. You can just click whatever device that you would like to, and after you click that device, you don't need to print any configuration. You can do it, but you can also have like some functions to turn on, some functions to turn off, and do whatever you would like using the GUI. All of this is happening using the DNA. Okay, so the DNA, like WLC, but it's to control your entire network. All right, after that we have, let us finish our lecture with this last slide. Okay, we have another type of servers. Servers are just like computers, just like PCs, but they are having a much more specific components, higher components, higher specific parts, stronger components inside it. storing common data for users. This is the function of a server, so that inside the server you store a common data for all the users to use, so that this is like the data that all users need. Okay, something shared within the information of the company you work in, the information of the employees, something that available and common for all the users to need. Just like these are the users and these are the end devices, just like I told you, a normal PC, an IP phone, a printer, or whatever. Even servers are called end devices. So the servers are PCs, but I'm sorry, as a hardware matter, it is a computer, but with what? Just like we mentioned, with higher specifications, stronger CPU, stronger RAM, tons of hard disks to store information in it. This is a function of servers. Servers can have very small amount of what we call port density, so it is better to connect your server to a switch, and after that this switch is connected to all your network, and all of the network will have the ability to connect to the server through the switch and obtain the information they need. From the beginning of the devices until now, always say that who makes the benefit of routers, switches, firewalls, and devices, servers, are the PCs or the computers or your mobile phones. PCs, computers, printers, mobile phones, the ones that make benefit of all these devices are called clients. So you have two terms in here. You have servers and clients. Okay, clients are the devices that consumes or generates the new data. So because generating data, that's because of the data that you have in your PC and you like to export it to the network or to the world. That's generating data. Consumes is taking an existing or already existing data from the network or from the internet, from the outside world globally to your to your own personal computer or end device. This is called clients. So right here we have servers and clients we talked about. Lastly, we have, why is this 8? I'm sorry, this should be type 7, maybe because the real 7 was the client and I say type 8 for here, no problem. Virtual machines, this is something introduced newly in this chapter. Virtual machines, we will have an entire subchapter for it. We will talk in detail about virtual machines in the end of this chapter, not in the next chapter, it's in chapter 1. Virtual machines, briefly, if we want to talk about, are any network device but in the virtual form. Virtual machine can be a PC, a router, a switch, a firewall, an IPS, a server, whatever you like, all of them. It can be in a virtual machine. Okay, we will talk about this in detail in the upcoming lectures. Okay, I hope this has been informative for you, and thank you for watching.